10.6 Quadratic Formula and the Discriminant. In this lesson, we'll look at how to determine the number and nature of solutions for a quadratic equation by using the discriminant. First, let's talk about how we can derive the quadratic formula. We do this by completing the square, except we're going to do it with the variables instead of with numbers. So we already kind of started this last lesson, so let's just start it here. We're going to subtract our c. That leads us to 8ax squared plus bx equals negative c. And then remember, we're going to divide by the a. Everybody gets divided by the a. Okay, great. And then we have x squared plus b over ax equals negative c over a. And then remember, we're going to take this term right here and we're going to multiply it by 1/2, which is going to give us b over 2a, and then we're going to square it, which is going to give us b squared over 4a squared. Then we're going to add that to both sides, plus b squared over 4a squared plus b squared over 4a squared. Okay, now we're going to factor this side, which is going to be x plus b over 2a. Remember, we always take the thing that we squared, and that's going to go inside our factoring. Squared equals, oops, I made a mistake here. That should have been an a, not an 8. Sounds similar in my brain. Okay, so we need to combine these here, and we need to find a common denominator. So obviously we're not going to be able to get this one down to a, so we're going to have to take this one to 4a squared. So we're going to multiply it by 4a on top and bottom times 4a, and we combine those together to get b squared minus 4ac all over 4a squared. Okay, then of course we need to square root, so we're going to square root both sides. Here we go. Okay, this is what we're left with after we square root, and remember, this is going to be plus or minus. And then we need to go ahead and get the x by itself, because we're trying to solve for x. We're trying to find the solution to the equation. So we need to subtract the b over 2a minus b over 2a. Okay, now we can do a little simplifying here. So we can say x equals, if we split up this radical here and actually apply it to the bottom, that is a perfect square that we could simplify. So we're left with plus or minus b squared minus 4ac on top, but the square root of 4a squared is 2a, so we have 2a on the bottom, and now we can actually combine these, so minus b over 2a. So what we can do then is just add this to the numerator, and we put it in front here, so we have negative b plus or minus the square root of b squared minus 4ac, and now it's all over 2a. So we can go ahead and erase this because we've accounted for it, and we're done. This is our quadratic formula. So then within the quadratic formula, which is a formula that solves for solutions to a quadratic equation, this term right here, the b squared minus 4ac, the one that's inside the radical, is called the discriminant. Now the discriminant is important because it's going to give us information about the root. So remember, when you're solving for x, you're solving for the root of the equation. But remember, when we were graphing, you think about it, the roots are where it crosses the x-axis, right? So sometimes you can have none. Sometimes you can have 1 if it just touches right there. And sometimes you can have 2 if it goes all the way through, right? So what the discriminant will help us then is see how many roots do we have and what kind of numbers are they. So if b squared minus 4ac equals 0, think about what that would mean for our quadratic formula. We would have negative b plus or minus, and the 0 would be inside the radical sign, over 2a. The only possible solution for x there is going to be negative b over 2a. Therefore, you would only have one root if your discriminant equals 0. And in addition, we know that that root is going to be a rational number because we can clearly see here that it can be written as a fraction. Next, let's talk about if the discriminant were greater than 0. Let's think about how that would look in our quadratic formula. We'd have negative b plus or minus a positive number in here over 2a. So we're definitely going to have a root. If b squared minus 4ac is a perfect square, then we're going to have rational number roots. If b squared minus 4ac is not a perfect square, then we're going to have irrational roots. So that was 2 rational roots. 2 irrational roots are possible based on if it were a perfect square or not a perfect square. And just to reiterate, but you may have noticed this already, because it's the plus or minus, that's where we get the 2 roots. And finally, let's see what happens if the discriminant b squared minus 4ac is less than 0. For our quadratic formula, that would look like this, plus or minus a negative number. And we can't do the square root of a negative number, right? So that's just, we can't do it. So what happens here then is that we have no real roots. So then, although the discriminant doesn't actually tell us what the roots are, it gives us an idea what we should be expecting for the roots. And if we're going to have no real roots, it can save us that time of trying to go through our factoring or completing the square or whatever it is and not getting anywhere with it. Right, so let's look at this one here. We'll identify our A. Our A is our invisible 1. Our B is negative 10. And our C is 25. And remember, our discriminant is b squared minus 4ac. So we need to put in our numbers here. That would be negative 10 squared minus 4. A is 1. And then C is 25. So we're going to have positive 100 minus 100, which equals 0. So our discriminant equals 0, and so remember that means we have one root, and our one root is going to be our negative b over 2a. So then it's pretty easy to go ahead and find that one solution, right? All we'd have to do is throw that in there, 2 times 1, and x equals 5. To practice, let's do try these number 1 to 3.